4.3 out of our book. That's all right. Caden wasn't paying attention. That's fine. So 4.3 talks about what we refer to as the square root method. There are lots of ways to approach solving equations, particularly quadratics, and one of them is the square root method. And the square root method doesn't always work. The equation kind of has to be set up the right way. There is a rather advanced way to force an equation to use the square root method, but we're not going to get into that today. So the simplest form of the square root method is x squared is equal to a number, and let's start with like the number 9. What is the answer to this equation? Something squared is equal to 9. And the answer is 3. But we're now at a place in your mathematical understanding where we have to think a little harder about what this means. Are there any other numbers times itself that equals 9? -3. So it turns out this equation has two answers. X could be equal to 3, but it could also be equal to -3 because negative times negative is positive. So the negatives cancel and we end up with 9. So whenever we do the square root method, you're always going to get two answers. Okay? And algebraically, we have to have a way to undo this situation. And if I had 2x equals 4, what's the opposite of multiplying by 2? Dividing by 2. Or if I had x minus 1, what would I do? I would add 1. I would do the opposite of the operation that's in place. What is the opposite of a squared? It's not, it's kind of like the divide version of a squared, but we call it the square root. The square root is the exact opposite as a squared. And it's easy to figure out. What is 8 squared? 64. What's the square root of 64? 8. So squares and square roots are opposite operations. If I have an x squared and I want to undo it, what do? Take the square root. We'll get into that. Good. That's a good question. Hang on to that for a little bit. Okay. So I'm going to square root 9. And there are two things I want to point out here. First, there is a little 2 in there that we're too lazy to write. And if the number inside the root and the number of the exponent are the same, then that's sort of like doing this and canceling those. Just like -1 and +1 are opposites, the squared and the square root are opposites, so those cancel. On the left side, I'm just left with x. And on the right side, I end up with 3. But we know there are more answers than that. So anytime you undo an x squared using a square root method, you have to put plus or minus in front of the square root. Because there are two correct answers to this. Yeah, and instead of doing this, because we're lazy, mathematicians are super lazy. Whoa, there's a keyboard. We just do plus or minus. And if you're in Google Docs, there is a symbol that has plus or minus. So if you're typing in Word, there's a plus or minus symbol. Every what do you call those? Every program. Yeah, they all have one. What do you call those? Yeah, what? Composition document? I don't know. I'm a math teacher. Don't ask me those questions. So when we undo squareds using the square root method, we always end up with two answers, a positive version and a negative version. Okay? What's that? I know. I'm so negative. If I had x squared is equal to 121, Then I undo the squared. And when this cancels that, I have to put plus or minus, and I get x equals plus or minus 11. Which means this equation has two solutions. Both 11 and negative 11 are appropriate answers. Okay, let me go one step further. What if I had x squared is equal to 24? Well, I do the square root method. This cancels that, and I have to remember the plus or the minus, and I get x equals plus or minus the square root of 24. But like we learned previously, 24 can be simplified. How do we simplify a square root? I factor it out, 4 and 6, 2 and 2, 3 and 2. And I ignore everything that factored, so those don't apply. And I look for pairs. Here is a pair. For every pair, what do? I bring one out. So now there is a 2 in front of the square root. So plus or minus 2, square root of, what's left? 3 times 2 is 36. So the solution to x squared is equal to 24 is plus or minus, oh boy. Sorry, guys. Hey, from now on, just listen to what I mean. Don't listen to what I say. So plus or minus 2 root 6. Is everybody okay with that? All right, let's make it one step more difficult. What about x squared minus 3 is equal to, let's say, let's do 33. Now I have to do two things. I need to get rid of the minus 3, and I need to get rid of the squared. Does it matter which one I get rid of first? Yes. So which one is the furthest away from x? The 3. So I need to move the 3 first, and then I'll remove the squared. So I add 3, and I get x squared is equal to 36. And then I take the square root. When the squared and the square root cancel, I need to remember that there's a plus or minus on the other side. And I get x is equal to plus or minus 6. Okay, which means when I plug in 6 to this top equation, 6 squared is 36, minus 3 is 33, it works. When I plug in negative 6, negative 6 times negative 6 is 36, minus 3 is 33, and we're good. Okay, now, this is a little bit different. Squared equals, let's say 16. Yeah. Now, I have to undo a plus 1, and I have to undo a second power. But which one is further away from x? The squared is. So that one needs to go first. Right? I have to peel this apart from the outside in order to reach that x on the inside. Now this is a little bit weird. We take the square root, and when the squared cancels the square root, what do? Plus or minus? When the squared cancels the square root, we always put plus or minus on the other side. Now I get x minus 1 is equal to plus or minus 4. Now here's where it gets weird. Add 1, and I get, don't say plus or minus 5. That's a really, really common mistake. So there are two answers, and they're not the same number. 5 and negative 4. Or no, not 4. Sorry. 3. So we do 4 plus 1 and negative 4 plus 1. So my plus or minus has now split into a 5 and a negative 3. Now watch what happens when we plug those in. So let's plug in 5. 5 minus 1 is 4, and 4 squared is 16. And then negative 3 minus 1 is negative 4 squared is 16. You see how that works? You could. Yes. That is one way to do it. They are about to get so complicated that even I don't want to mess with that. But you're right. What we're saying here is, what numbers can I subtract 1 from and then square it and get the number 16? And you can reason through that and say, well, 4 squared is 16. So what number minus 1 is 4? Well, 5. But negative 4 squared is also 16. What number minus 1 is negative 4? Negative 3. So yeah, you can do that. Yeah. All right, what about this? Holy cow. So let's look at the x and figure what is the closest to it. So what happens to the x first? This is step 1 for the x. And then this is step 2, and this is step 3. Does everybody understand that? Now, in order to reach the x, we have to peel the layers apart one at a time, starting on the outside. So what do I do first? Add 3. So the goal is to reach the x. The first thing that happens to x is the 2. The second thing that happens to the x is the squared. The third thing that happens to x is the minus 3. Right. So if this was a piñata and I was supposed to pull it apart, if I want to reach the candy, I've got to take out the outside layer first. Equations are like ogres. They have layers. Yeah, you have to strip away the outside layers first. So we subtract 3, and now it equals 9. And that cancels, and I have x plus 2 squared. Now what? Just take the square root. And anytime this cancels that, we have to do plus or minus. Now I have x plus 2 is equal to 3, but it's a plus or minus 3. Now I subtract 2, and I get 1 and negative 5. Now, don't write your answers like this. What's wrong with that? That's an x comma y. These are both x's. So we put that over in the right spot, and we write x is equal to 1 and negative 5 at the same time. Now, could you do this one in your head? Well, it's a little more complicated. Let me get these out of the way. So we want some number plus 2 raised to the second power minus 3 equals 6. Well, what number minus 3 is 6? 9. So the squared has to equal 9. What number squared equals 9? 3. And then what number plus 2 squared will equal 9? 1. So that one gets really complicated. So 1 plus 2 is 3. 3 squared is 9. 9 minus 3 is 6. But negative 5 plus 2 is negative 3. And negative 3 squared is also 9. Minus 3 is 6. So for the simple ones, you can kind of work it out in your head. But for these more complicated ones, it doesn't really work out that way. All right. Let's do this. Okay, hold on. This is going to take some effort in my head to make it work. All right, so nope, let's make that a 5. Hold on a second. Okay, we'll see if I did this right. So looking at the 6, what is or the x? What is the first thing that happens to the x? This. What's the second thing that happens to the x? Is it the exponent or is it the times by 2? Exponents are above multiplication. But wait a minute. Why did I label subtraction as the first one if that's way low on the list? It's inside the parentheses. Good. You guys understand how to do this. So the first thing that happens to the x is the 6. The second thing is the squared. The third thing is times by 2. And the fourth thing is the plus 5. So I get rid of plus 5 by subtracting 5, and I get 50. Then what? Close. Divide it by 2, and I get x minus 6 squared is equal to 25. Oh, good, I did it right. Okay. Take the square root, and I get x minus 6 equals, good, plus or minus 5. Now I add 6, 11, and positive 1. 5 plus 6 is 11, so x equals 11. And negative 5 plus 6 is equal to positive 1. Do you guys understand that? There's only one thing I need to add to this, but do you get that? Cody, where are you lost? What? Oh. Okay, well, the steps, in this case, the steps are always going to be the same. Inside first, then the exponent, then you move to the outside. Okay, so that will always be the same. Now, 3, yes, it does matter. So if I divided 55 by 2, I would get 22.5, and then subtract 5, and I would get 18.5 instead of 25. So yeah, the order does matter. So it is the order of operations in reverse. So our numbering system, 1, 2, 3, 4, 1, 2, 3, 4 follows order of operations. And then when you start peeling back the layers, you just go in reverse order. So instead of saying, do the order of operations in reverse order, we label the order of operations and then just do them backwards. Yeah, that's why numbering those numbers really helps. Hey, let me show you what else can happen. Something like this. X minus 3 squared is equal to 72. Anybody see a problem with that? What's going to happen here that hasn't happened on any of the plus or minus problems yet? 72 is not a perfect square. So I'm going to solve it just like I did before. Step 1, step 2, reverse order. Take the square root, and I get x minus 3 is equal to plus or minus. We have to simplify 72. It doesn't come out evenly. So 8 and 9. 8 is made up of 2 times 2 times 2 and 3 times 3. Are there any pairs? Pair of 2s, pair of 3s. What goes on the outside? 2 times 3, which is 6. What stays on the inside? 2. All right, let me stop there. How many of you get that? Okay. Those of you who are stuck, where did you get stuck? Right. Now, I need to add 3. And for you, it would be natural to do this. But nobody in the math community writes it that way. Okay? Everybody puts that number in front of the square root. Why? I don't really know. So instead of putting the plus 3 on the right, we're going to put it right here. And we get x equals 3 plus or minus 6 root 2. Yes. Technically no, but no, you will never see a square root written that way. You will never see plus or minus 6 root 2 plus 3. Nobody does it that way. Yeah, the answer is the bottom one, and that's actually 2 numbers, right? It's 3 plus the square root of 72 and 3 minus the square root of 72. But it looks like one number. And perhaps the reason we write it that way is that's one fewer sign. I told you that mathematicians are lazy. Do you see how that has one extra sign? I don't really know the reasoning. I guess in the future it does make certain things a little easier if you write it 3 plus or minus 6 root 2, but whatever. Whatever the reasons are, that's just how it's done. Okay, let's do another one. Let's do x minus 4 squared plus 1 is equal to 10. Nope, not 10. 13. Let's label our order. Oakley, what's first? Good job. You get it? The only other thing is, if there was a number here, that would get the 3rd step, and the 1 would get the 4th step. And it's the same. All these problems are going to be the same. Inside squared, outside, and then the end. Okay. So I'm going to subtract 1. And I get x minus 4 squared equals 12. And I am going to require that you write all this down. You have to show the steps. Now I take the square root. And anytime a square root cancels a squared, you need plus or minus. That yields x minus 4, which is equal to plus or minus, well, 12 is made up of 3 and 4, which is made up of 2 and 2. Can I bring anything out? Pair of 2's. 2 times the square root of 3 is the only leftover. And then we're going to add 4, and we put that right here. So the answer is 4 plus or minus 2 times the square root of 3. Now, what if this was already a plus 4? Then we would subtract 4, and it would end up looking like that. Negative 4 plus 2 root 3. Okay? All right, so 4.1 or 4.3. Your problem set is one through 29 odd. Nope, not in 1. Sorry, 3. 3 through 29 odd. Okay, and some of them are a little tricky. They're they do get a little bit tricky, but you should be able to handle those.